One wonderful aspect of CU and the program, I think, is to meet people who are, your friends and collaborators, and after years and years, you still have no idea what they are talking about. But at the same time, you feel like you don't need to know. And I think that's fantastic that you can trust them. They know what they're doing. I don't need to know. And that's very good. Okay, so as I mentioned, one of the cool new things we are having here is a collaboration with GitHub. So it's my pleasure to introduce Kevin Shu. He's a senior software engineer at the Policy Unit. And Kevin, take it away.
All right, perfect. Beautiful. Hello, everyone. My name is Kevin Shu, and I'm a software engineer at GitHub. And specifically, I'm at the GitHub policy team. What I want to go through today is first just an intro about myself. So as I mentioned, I'm a software engineer at GitHub, and my career journey was pretty traditional. In my undergrad, I studied biology. And then after that, I went to law school. After graduating from law school, I joined the clinical faculty over at Berkeley Law for about 5 years, taught at a clinic. And throughout that time, through a roller coaster series of events, I found myself just getting addicted to programming, just like solving these programming puzzles. It was so much fun. I would do this in my nights and weekends, and I couldn't help but, one day I was like, man, I really want to do this, during the daytime. Right, and eventually I made the jump into software engineering, one of the things that come to mind for this within GitHub, I am the first and so far only software engineer, that's my title, within the legal department of GitHub, and so I thought I got out, but they pulled me back in, in terms of the kinds of work that I do as the technical person within the department. Oftentimes they ask me to do some data analysis, data science kind of work. Now, notice that undergrad in biology, law degree, software engineer, self-taught software engineering practice. I didn't include a econ PhD, so I don't have that. And so when it comes to the causal analysis questions that might come up, it's mostly the case that I would collaborate with external economists to actually get credible, unbiased estimates of causal effects. Right? But for descriptive, I can somewhat handle that. With predictive, still need some help. But yeah, especially with the causal questions, those are generally the questions that move the needle when it comes to these policy questions. We rely on and are very grateful for any help that we receive when it comes to external economists. Now, one thing that I do want to mention is that, Karsten, as he opened this program, he mentioned that CEU offers a broad exposure to methods and a thorough education in methods and techniques through this program. And this is something that, I often say that I am not the engineer, lawyer, data scientist that my team deserves, but I am the one they got. I am very envious of all of you who attend CEU to become students here, because I believe so much in this program that internally within GitHub over the past 1.5 years, we've had an internal book club going over the Gabor's textbook, Data Analysis for Business, Economics, and Policy, going through all these methods, although we are in the last 2 chapters of this textbook after 1.5 years. And so, in the coursework that you cover in 1 semester, it's just a short, 2 years later, we'll finally be finished. So you never stop learning, even in industry. First, let's go into, what does the GitHub policy team do? I know that these are probably very tiny font size, but broadly speaking, we fight for developers' rights to be able to innovate, to try to participate in open source and share knowledge into the public, contribute to the public commons. Right? And oftentimes there are intellectual property laws or regulations that might create some chilling effects for what developers are allowed to do. Often there are trade controls, export controls, and trade sanctions that might prevent folks who might want to participate in open source software. And so some of our work entails making GitHub as globally available as possible within the law. And so we do some work when it comes to enabling access to Syria, as well as making it available in Iran. One thing that I do want to call out is that this bottom right square, this question of open source creates value, but how do you measure it? It is very difficult to measure something that doesn't have a price, right? You don't pay every time you download pandas. And so building up the evidence base for figuring out like what is the economic impact of open source software. That is something that we're very much interested in, as well as many other questions around collaboration and the impact of generative AI and then all that. And so one of the descriptive data tasks that I've been involved with is something called the GitHub Innovation Graph. This is a publicly available data set on public software development activity happening on the GitHub platform. Our goal is to provide quarterly aggregates so that economists, researchers, developers, policymakers, they don't have to hammer the GitHub API for weeks and weeks and weeks to try to get some data to even find out if there's a there. So we provide these very aggregated data sets at the economy level, which mostly corresponds to like country level. Diving into one of these CSVs, you can see a nice tidy data set showing United States Git pushes, the code uploads for a particular year, quarter, year of observation. And then, we have, here's a list of the possible metrics that we provide. You can feel free to read through those, and they are available in the GitHub Innovation Graph repository that includes a data sheet, because as I know from Gauber's textbook, it is important to document all of the analyst decisions that go into even compiling such a data set. But once we have this, we can provide some nice charts. Right? This is something that you can get at least some idea of the aggregate activity happening within GitHub. At least when it comes to public repositories, you can see some pretty rapid growth, and you can see this overtaking of the US by the EU in Git pushes in these later quarters. Right? And have a dramatic rise when it comes to India and Brazil and many other economies. For repositories, you can see similar, we always like charts that go up and to the right, and many of these metrics, you see similar things. You can see India overtaking the EU in terms of repositories created. Right? There are other chart types that you might be interested in. For example, is the rankings of programming languages. Right? You can see the utter dominance of JavaScript, and as you'll see actually later on, this is very important for in terms of documenting the decisions that went into how we're coming up with this data within the data sheet, because this there's some tension between this and what Alex presented with Python being greatest percentage share, right? And that has to do with what were the conditions required that is represented in this data. In this case, this is the number of unique developers who pushed at least one push to a repo that contains at least one of these languages. So that's just a very, it might be a different definition than other data sources. Right? And then, okay, so there's another point that Alex made in his presentation about kind of the role of marketing, right? So within industry, it's not every day that you're going to be trying to publish an article in a peer-reviewed journal, right? Sometimes you just want to make some interesting marketing material to put on social media, right? And this is something called a bar chart race. So looking at the line plots, the static line plots that I showed earlier, they are very useful to kind of figure out, like, oh, this is the trajectory of these various metrics across these economies, but it might not reflect the kind of living, breathing system that is producing these things, or at least the living, breathing people who are generating data as part of this process. Right? And so there is something called a bar chart race kind of data visualization type that got a confusingly large amount of engagement on our social media for a data chart. And I think I have to click this okay. So United States and European Union are up on top. My initial reaction is USA. USA, and I'm sure you have other reactions, but you all see the rise of Brazil and the rise of Japan, but I look back and I see, man, EU is getting scarily close to overtaking the United States. There's some suspense that's happening. Are they going to overtake it? Are they going to do it? It's so close, and they do. Right? That's magical. Right? That's really cool. Now that being said, this data visualization type in data viz circles, it's regarded as the fidget spinner of data viz because it's analytically, it's really difficult to actually track like how quickly things are moving on a moving image. But there's something to be said about trying to increase engagement and like inviting people to question the data and like dig deeper into the data themselves. Because there's lots of different ways to slice and dice this data, and would welcome ideas for taking different cuts and different ways to visualize stuff, right? And so one thing that's really interesting about providing a public aggregate data set like this is that folks that who don't work for you, they just appear out of the woodwork to maybe create a paper based on that data. So Alexander Quispe and Rodrigo Grijalba, they took the innovation graph data set and created this synthetic Diff-in-Diff kind of analysis to see the effect of ChatGPT availability on these innovation graph metrics. That's really cool. I don't have an econ PhD, but you can chat with the researchers do that. But I think it's just pretty amazing to be able to enable such research efforts. Right? And then separately, Jeff Gortmaker, incoming NYU professor, he used some demand estimation techniques to, the goal was to figure out like using simulation exercises to see what would be the effect of China or the United States either subsidizing open source software or adding disincentives to it as policy questions. And one of the things he did was he scraped Git in order to figure out like what is the impact of certain network restrictions that China provided or put into place on the number of active contributors on Git versus GitHub. And the way, so you can dive into his paper to see more details, but he used innovation graph data to give a ground truth like sanity check to see if his estimates of the difference in monthly active contributors was true, because he was using GitHub user profile data, like self-declared on the location versus IP address geolocation, because within China there is a VPN use that would mess with the geolocation assigned to these users. Another project that I work on is the GitHub Octaverse. I invite you to check out that blog page. It is a very large narrative report that comes out each year around GitHub Universe. And you'll also notice this is another situation where the data definitions might change and might change the results. Right? You can see TypeScript going to number 1. And that might not accord with other rankings, such as within the GitHub Innovation Graph. And it's because you just have different definitions of that data. Right? A predictive project that actually Alexander Quispe, after he made that synthetic Diff-in-Diff paper, he ended up joining us as over the summer on just a research associate basis to classify repositories by this North American industry classification standard code, because we felt like it would be really useful to get a sense of what is the kind of proportional share of these different industry codes on GitHub. It would be useful to be able to say to a policymaker, like, hey, this we have this many repos on GitHub, these public open source repos on GitHub, and X% of them are related to manufacturing or utilities or mining or healthcare. And so results, this is still preliminary, but we with some random sampling and back of the envelope histograms, is pretty interesting to be able to see between different economies the relative proportion of these different sectors. Right? So obviously at the bottom is the information and media sector. That is one of the NAICS codes, and it is by and far the largest. Right? And this is pretty similar across different high-income economies. It is also interesting to see differences in just like top 3 rankings. If I remember correctly, South Korea, they have like arts and entertainment and recreation as like pretty high up, and maybe it's because of their sheer dominance when it comes to K-pop and like esports, competitive esports. But when you compare that to like lower income countries, the largest bar here is educational services. Like, and our kind of hypothesis is that maybe like a lot of the developers who would be pushing code into public repos within these lower income countries, they're students or faculty within universities. Like that's where you would regularly get access to the tools and to to engage or to make code and put them on GitHub, and then work on these kinds of projects, as opposed to in industry within these lower income economies, you just might not have that opportunity or have that kind of day job. Right? One thing that I'm quite proud of is an example of a causal analysis that I performed without any like fancy observational causal inference techniques. So this this has to do with why I was actually hired at GitHub in the first place. So the DMCA is a copyright law where platforms need to accept takedown notices and review them and take down infringing or allegedly infringing content from the platforms. Right? And there is a particular section of DMCA called Section 1201 that deals with these anti-circumvention or the circumvention tools. Typically, this would be dealing with DRM kind of techniques often used within DVDs or many of you probably don't know what DVDs are. Like Netflix streams, they're encrypted with some kind of secret key, and you're unable to kind of just like download that locally on your machine and then reuse that over and over. That would be a canonical kind of DRM kind of scheme, and something that would violate Section 1201 under these anti-circumvention provisions. So we do track how many allegations of circumvention that we receive. And you notice that, well, this line's pretty tiny, but maybe I can use my arm here. So through the year of like 2021 until like October, the line is basically like maybe like 2 notices per month. Right? And then starting from October, it rises drastically to like 30x per month, right? And that's pretty weird, right? That is, it's probably, generally, event studies where you just say like, oh, something started at this date, they are kind of riddled with bias because a lot of things happen at the same time in this world. It's pretty complicated. But these like times like these where it would be really useful to have a distributed version control system that contains like time-stamped entries of every time you change your source code, right? Because what happened in September 29, 2021, this beginning of October event, was that we added a question in our DMCA form that asks, like, hey, are you alleging that this project contains some kind of circumvention tool? And often, apparently, when people submit these takedown notices, when they go to that question, they're like, yeah, that sounds bad. So yeah, there definitely has a circumvention, something's about circumvention there, right? And at the same time, we did, simultaneous with the form update, we added an annotation to these notices to say, like, hey, even though the person alleged that there was a circumvention kind of claim in there, we decided to process it on other grounds because it just seemed like more like vanilla copyright infringement and not circumvention. And that's this blue line here. And you can actually see that there wasn't an actual increase in circumvention kind of related tools. It was just like people started saying that that this project contains a circumvention tool just to try to bolster their case to get it taken down. Right. Lastly, these last 2 ones are more causal estimates that we collaborate with, like actual people who have PhDs in econ. So this was a Diff-in-Diff analysis that the LinkedIn economic graph team did in collaboration with us. And they matched these LinkedIn kind of companies with GitHub companies that adopted GitHub Copilot. One thing that's interesting is that this was not the sign was not like negative, right? Like people who adopt or companies that adopted Copilot, they seem to hire more, right? And interestingly, like the hires, they listed like more non-programming related skills onto their profiles. Another causal inference project that we collaborated with folks from HBS was this program. Well, it was this study to see the impact of our GitHub Copilot like free access program, where this kind of predates back when GitHub Copilot, we didn't have a free tier, but we did offer GitHub Copilot for free for top open source maintainers. And the way that worked was that we'd had some internal ranking for repositories, for repos within GitHub. And if you made it past some threshold, you would be offered GitHub Copilot for free. And so this lended itself nicely for a regression discontinuity design. And from there, long story short, the average treatment effect seemed to be 5.4 percentage point increase in the proportion of coding activities that they performed, and a 10% percentage point decrease in project management activities, which have to do with like opening pull requests, reviewing them, closing issues, things of that nature. And so on the one hand, you might say that basically the question is like, what are these maintainers doing? And what it seemed to be that like often when you go into open source software, you went in because you really loved coding, right? You like Alex, you might have made some project that really was useful for your work, but as the project grows, maybe over a longer and longer time frame, your work becomes more and more project management as opposed to actually building features, like writing code. And it seems like from previous surveys from the Linux Foundation that that often led to like maintainer dissatisfaction and possibly higher burnout. And so the question would be, whether this might be good from an open source sustainability angle, just so that the maintainers, still are able to do more and more of the things that they love and less of the things that they don't. At the same time, there's a clear danger that this might be reducing collaboration within open source software. And those are interesting questions that we should explore more in future research. And with that, I will open. So these are individual coding effects and project management effects. And there are heterogeneous treatment effects on programmers that have like lower ability. They seem to be performing more coding activities. Okay, yeah. Nice. Okay, yeah.
2 more minutes, don't worry.
Sounds good. Yeah, maybe if you're interested, particularly when it comes to the coding effects, these were the activities that they categorized as coding related. And you can see that there was like the increase in activity was generally driven by these two types of events, like creation of repos and pushed commits. And these corresponded to things that the maintainers could do themselves, basically. They kind of took the reins and decided, well, I have this fun, cool generative AI programming tool. Maybe I'll try to build these features that I always wanted, but maybe I didn't have the time or expertise for before. Maybe I didn't really know how to write Rust, right? Maybe I wanted to try to dive into C kind of bytecode or something. And the existence of this tool, maybe it helped them go past the activation energy required to take on these new projects or something. And then when it comes to the project management effects, so these were the activities that saw a decrease, right? They requested reviews on their issues and pull requests less. They subscribed to issues less. They reviewed pull requests less, and they assigned issues less. They had a bit more when it comes to merging and closing issues, and these are the kinds of activities that they could unilaterally do as maintainers, right? Didn't have to go through some back and forth discussion with other collaborators. And then these are the heterogeneous treatment effects. They did a median split across these various proxy variables for the latent variable of ability. Like, what is ability? There was a max centrality measure looking at the number of or proportion of commits associated with a particular project. There was a achievements one related to our badges that we provide on GitHub, and then followers. But for each of these different proxies, it seemed like the lower ability programmers, according to this median split, they saw like a greater increase in coding activity compared to the high ones. And then similarly, when it comes to project management, this effect was more pronounced in the low ability coders when it comes to that median split. And maybe now I'll open it up for questions.